Welcome. This is a video showing you how to set up your HackRF1 on a Linux system. I'm just currently running Kali because it's one of the systems I have right now that doesn't have this set up, but I have set this up on a Raspberry Pi 5 running Ubuntu server, and then I have also tested it on a dual boot of Fedora Linux, and they both have worked fine. And these installation instructions can be repeated on most Linux systems, and you might just have to change a few things. I will also link in the description all the documentation I followed and resources I used. So, one of the first steps, just making sure your system's up to date. I've already run these commands, but just to save time. But you just want to run these to update your system. Now, the first thing, make sure your HackRF1 is plugged into your computer. So because we're going to use it for testing, we'll first start with this command. It's going to install all the packages and dependencies that the HackRF1 needs to communicate with our system, including firmware, I believe. So now if we were to run a command that's built, that comes with this, that comes with the HackRF tools, sorry, you might need, it says permission 1 because you might need sudo permissions. So now we can see more information about our HackRF1. This is interesting. I didn't need to do this on other systems, but again, just adjust slightly as you're doing it. But if you were to unplug your HackRF1 and then run the same command, you won't have any outputs. No ports were found. So this is a good sign that that this command ran without any issue. Now what we're going to do, that's pretty much everything, almost everything needed for the HackRF1. Now we're going to install what's called SOAPy. SOAPy is just like an interfacing library that allows the HackRF1 to communicate with GNU Radio, which we'll actually be demonstrating later on. And specifically in GNU Radio, there are certain blocks that allow you to communicate with different types of hardware, and installing this is important to be able to use those blocks. So first we'll install some of the dependencies that that SOAPy needs. And I should just note that this installation won't be typical because we will have to build from the source. Because the libraries I think are written in C++, or the source is written in C++, CMake, G++, lib. Now we'll have these instructions somewhere, probably on a GitHub repository that will be linked in the description. So run this command. You might already have some of these installed, but it's good to just run them just in case. But just so we know, those packages that we saw, CMake, G++, those are for basically compiling C++ code and building it. The lib Python 3 dev, Python 3 numpy, those are related to Python. Python 3 numpy is just a Python package. And then lib Python 3.dev, I believe, is just extra tooling for Python. And then swig is a way to bind C++ like code to Python, because I believe GNU Radio, even though it writes a Python file in the backend, it is C++ code, but it's being binded to Python code. Alright, now since we installed those dependencies, now we're going to clone the repository. So what I'm going to do is clone and I'm going to have to hand type this because I don't have the link easily accessible, but we should be able to just copy and paste. And you should be able to store this repository anywhere, I believe. I'm just going to do it in my home directory, just for simplicity. Right, we've cloned the repository. Now we're going to, if you look, you can see it right here. So now we're going to cd into it because we need to build. So step 3. We're going to make the build directory. We're going to go into it, and then we're going to make, and the reason why is so that when we're making the build, it's going to be inside this build directory. Alright. Okay, it looks like it's just warning, so I think this should be fine. Now we're going to, again, these are just instructions from the documentation with some minor nuances and switches. Now we're going to do install. Alright. And then alright, cool. So now it should be set up on our system. So now what we're going to do, we should be able to talk about this command, and it's pretty cool. Alright, great. So this shows that we do have the library installed, but if you notice here, we have no modules found. SOAPy allows you to define modules using like their pre-built class, and different SDRs have modules defined. So I think there's one for the common sensor that's like the RTLS SDR that's in all the GNU Radio tutorials, and then they also have one for the HackRF one, like we'll be demonstrating in this video. So now we have to basically do the same process that we did for SOAPy, but for this module for the HackRF one. So we're going to just cd to home, and then now we're going to install kind of the same process. We're going to install the we're going to install the plugin for HackRF, the module. So what we're going to do is we're going to install libhack dev. I think it's just development tools for the HackRF one. Alright, that's installed, and then again, and then a big thing too, we're going to clone the HackRF. This also has a separate repository. Again, I have to hand type it, but you'll be able to copy and paste it. Make sure to put this in its own directory, or clone this into its own directory. Don't put this in the same folder or directory as the SOAPy SDR directory that you cloned, because this might just create some issues. So I think I have a small error. Oh. I think this is a, I believe, the GitHub group, and then this is the repository itself. Okay, that should work. Alright, so now you'll see it's SOAPy HackRF right there. Alright, now, like I said, kind of the same process. We're going to make the build directory. CD into the build. We're in the CMake. Just a warning again. It's fine. And then I'm going to do it. should have worked. So now, if we run the command scopy str except instead of info, we're going to actually equals to info. So we can see here now, look, we can find a supported module, the libHackRF support available factories. So to actually test that, make sure your HackRF1 is plugged in, and you can use a probe flag to basically probe a specific driver. In this case, our HackRF1, and unrecognized option. Oh, you spell it right. Alright, yep, it's right there. So, as you can see, is able to find it right here, which is great. And now finally, I mean, obviously there's a lot of software out there to work with software-defined radios, but for this use case, the reason why we're installing SOAPy is because it is supported in GNU Radio. There are certain SOAPy blocks in GNU Radio that just make it a lot easier. So now we're going to install GNU Radio, which is going to be a lot easier than what we just did. Just sudo apt install GNU Radio. Alright, so we now have it installed. So I believe there's a command for it, but you can also search for it here. So GNU Radio Companion is the GUI version. We can also unhook it, I believe, here by doing companion. Yes, so you can see here, we have it now installed, and you should be able to work with it. Well, actually, I'll pull up, I'll probably cut to it because I'll be recording at a different time, but I will be doing a demonstration of an FM radio receiver and transmitter that I built. I won't be going into the details of it unless it's desired in a future video, but I'll be showing how they work and how, and just demonstrating that the installation process works.
Hello. So, like promised, this is a demonstration of the FM radio. We'll first be demonstrating the receiver. I want to give some preface though. As you notice, the environment looks a little bit different. After the installation instructions on the Kali Linux machine, I noticed for some reason the FM radio receiver wasn't working for some of the stations, which is weird, and I don't know really why. So I will look into that in the future and hopefully try to figure out what that issue is. But right now I'm running Fedora Linux, as I mentioned previously it works on. So I'm going to just run this and show you. SDR is right there. Opening the door so there's a better signal. So this little knob's a little, just adding a little gain or multiply constant to that data stream. And we actually have a full scroller up here, so if you want to go to another station.
Listen to JRR on the iHeartRadio app. Just say, Alexa, play 101.1 WJR.
Alright, now this is the FM radio transmitter. Right now we have a radio station on an empty channel. That's why there's a lot of noise going on. But we have our SDR directed towards it. And that song that we listened to previously using the receiver, we're now going to play on this empty station. Turn up a little bit. As you can see, it's successfully transmitting. I think there's some optimizations that can be done or fixes to make it so that the signal's a little louder. You can tell it's a little soft. But yeah. After that, I just wanted to give some final remarks. So I will be putting in the description the link to the repository that has the installation steps that I performed in the beginning of the video, along with these 2 pieces of code, which will include the GNU Radio Companion binary that allows you to basically, actually I don't think it's a binary, I think it's just a configuration file that basically allows you to open it within GNU Radio Companion, the GUI you're looking at right now, along with the Python scripts that GNU Radio Companion generates. Additionally, I also put 2 links to 2 other videos that were helpful in designing both the radio receiver and transmitter. Both of them, for the most part, are carbon copies of the videos, besides the source blocks being different, or I guess the source for the receiver and then the output for the transmitter. But thank you. I hope I am able to do a future video where I maybe clean these up a little bit, maybe a high quality video. And yeah, please leave any comments or anything else.